Hello everybody, welcome to my second video, Unit 1, Day 2, Graphs of Inverses. You see a little bit about it here. We did inverse on Day 1, learned how to do linear ones, quadratic ones. Didn't do an exponential yet. May come across that at some point today or on Day 2. Need a couple of supplies for this. We're going to make a little graph. So if you're out of class today and you got this stuff, great. If not, just pick it up when you come in tomorrow. So before I start, I want to make sure you understand the vertical line test and how it reveals whether you're dealing with a function or not. Remember, if a vertical line touches a function one time, that's a good thing. It passes the vertical line test. But if it touches a function, potential function, more than one time, then that means that's not a function. So in these two cases, they touch twice, not a function. It's possible that you can have a function, but when you inverse it, it will no longer be a function. So that's kind of something that we have to test, and I'll show you how to test it. So in order to show you the details, I'm going to go back to one of the ones that I believe we did in class previously. So I took y equals 2x plus 6, which is this function in red. It has 0, 6 on it. It has a few other key points on it. When you inverse it, get rid of the plus 6 by subtracting 6 and get rid of the 2 by dividing by 2. Of course, I did all those steps. I'm not just typing something in. But nope. When I do those, the coordinates on the coordinates on my inverse, you may notice are flipped from their originals. So originally I had 0, 6. And now I have 6, 0. Originally I had negative 3, 0. Now I have 0, negative 3. Originally I had negative 6, negative 6, and if you flip that, I'm still at negative 6, negative 6. So all the coordinates are flipped versions from the original. In addition, another major thing about inverses of graphs, this line y equals x, which is this green line, it's always right down the middle basically, or you could say the two functions are symmetric about the line y equals x. Why do they call this y equals x? Because no matter where you go on this line, the x and the y are equal to each other, even in quadrant 3. In class, we also did one that was a second degree function, or a parabola, as you may know it, a quadratic function. Now note, this is a function. It does pass the vertical line test. But I know by using a horizontal line is going to touch twice. That actually tells me that it's not invertible, because once I inverse it, it's going to turn, I want to describe it as turn sideways. That's not really what happens. Kind of looks like that. When I inverse this function, of course, the minus 2 will turn to a plus 2. The square will turn to a square root and all that, if you want to work that out. And if you notice, it makes this red part, it looks like it's just half of a parabola. But remember, a square root graph has a positive and a negative version. Like the square root of 25 could be positive 5, could also be negative 5. So when I type in the other version of that, I forgot what I was doing with it. There. When I type in the other version of that, the negative version of that, I can see the rest of it. But note again, like I was saying, the inverse in this case is no longer a function. So it's technically the original is non-invertible. The inverse of the original is not a function. It's kind of like a technical style question. So it's just something to kind of notice and realize that the function doesn't always have an invertible function per se. You can still inverse it. Let's see what else I have in my slides. So a potential example we could do, some random notes about graphs of inverses. So you already know that f of x is for functions, mainly your original function, and the -1 represents inverses. -1 is not something that is recognized on Desmos in that case. Like you wouldn't type it in this way on Desmos. I'm going to show you this in a second. Desmos, oh, that's what I was just saying, boom. The horizontal line test to determine invertibility or no is something I already mentioned. So let me show you one other thing about Desmos. Let's say you're dealing with the function y equals 3x minus 8. If you want to see the actual inverse, and not necessarily do the work to find the inverse, but you want to see what the graph looks like, and I said this in class, but I didn't show this in class. When you switch the x and the y, that is actually the inverse, but it doesn't have y by itself. So what I was saying in class on the first day was, to be sort of mathematically correct per se, we'll get y by itself to present the answer, but these are still inverses the moment I switch the x and y. So again, you'll note that like 0 and 2.667 flips over here to 2.667 and 0. The coordinates are still flip versions of each other. 4, 4 flips to 4, 4. I can find other points in here I'm sure to click on. Looks a lot like the one we did earlier, of function and its inverse. Again, the original purple one there, if that's indeed the original, it's not invertible because, or the inverse is not a function because it fails the horizontal line test. Touching twice is a bad thing for inversing. Touching a vertical line twice means not a function. Touching a horizontal line twice means the inverse is not a function. Kind of a technical type lesson to deal with. Excuse me. So as far as activity in class goes, you're going to pick one of these 6 functions on your little graphing paper with your little construction paper slips. You're just picking one of these, whichever one you want to deal with. If you want to deal with something you haven't seen before, do the one with the third power or the cubic function. If you want to deal with a parabola, use one with a square or potentially square root. If you want to just have a regular straight line, do a linear one like the first power x ones, first degree. The directions, so you've already chosen a function. You're going to put your original function in Desmos, use graph paper and a ruler. Keyword, use the ruler, especially if you have a straight line. There's no ruler that we have for parabolas. And do the original in one of your colored pencils. So maybe it's in green. You're going to do the inverse work on a sticky note to the one that you chose. And once you get your inverse, you're going to graph that one on Desmos and put that in a different color. So you'll have like a green graph and a orange graph or something like that. 2 different ones. I should be able to tell the difference between your 2. You're going to, on 2 strips, show any set of coordinates are flipped. Like I showed you, 2, 7 would flip to 7, 2. Oh, I think I skipped 6. You're going to label the y equals x line on a strip. So write y equals x on a strip. And make sure you put the y equals x line. As I said on step 5, put the y equals x line. Use a ruler. Attach the sticky note on there. Remember, the sticky note has your inverse work on it, as your first and last name, the date, class period, all on the front. Put all that on the front. I don't want to have to flip over to the back. Add some kind of inverse title, and glue sticks are on the table if you need them. Make sure you clean up, and thank y'all for watching.